Welcome to this three-part series on writing a CER. Now, a CER is basically a scientific explanation, but it's much easier for us in class just to say, hey, we're going to work on writing a CER today, or we're going to have a CER test. The C stands for claim, the E stands for evidence, and the R stands for reasoning. And we're going to break it into three different videos. Part one will be for the claim, part two for the evidence, and part three will be for the reasoning. Now, this video can be used for those of you who are new to class. So if you're not here in the beginning of the year when we do a lot of practice, refer to this video, or I will refer you to this video so that you can brush up on how to write a good CER. Now, claim. Claims are statements that answer your original question or problem. The claim is usually one sentence in length, and it must be accurate, specific, and completely answer the question. So the completely answer the question is important. Try not to answer your claim with a yes or no answer. One, some of you may argue that, well, it's a sentence, and so it should be good, but it has to completely answer a question. So we're going to do an example today together in this video. This graph that you see here represents the relationship between the amount of spring rainfall recorded at a pond and the number of frogs in that pond. The data was collected over 5 spring seasons. So let's look at this right here. So we see that there's 5 different dots, and so I'm going to assume that those are the 5 seasons that the data was collected. Here on your y-axis, you have the number of frogs in the pond, and this is dependent on the amount of rainfall. So this is going to depend on the amount of rainfall. And you can see that it goes up by 10. So for example, in one of the years, we had the amount of spring rainfall in centimeters. There was 5 centimeters of spring rainfall, and they found 20 frogs. We go down here, and here's another example that there was approximately 20 centimeters of rain, looking at the graph, and it's right on, so it should not be approximate, it should be exact, and there was 60 frogs found. Now when you get into some of these spots right here, you're going to have to estimate how much rainfall you had with how many frogs that you found. So when we go to the next slide, here it is. This is the question that you're going to have to answer. What is the relationship between the amount of rainfall at the pond and the number of frogs in the pond? So remember, your claim should be a full sentence. It should be accurate, specific, and completely answer the question. Now, one of the things that students will often do right away is they'll make a claim. This is what they think it is. But what I'm encouraging you to do is you actually need to look at your data first. And so sometimes it's easier to find the E or the evidence first, to look at the evidence and to see what would support a claim, because your claim is supposed to be accurate. So when I look at this, when there was 5 centimeters of rain, there was 20 frogs. When I look right here, it looks like there's about 8 centimeters of rain, and there's probably about 33 frogs found. And then when we go up to, this looks like it's about right in the middle, so we can even call it 12.5 centimeters of rain. The number of frogs went up to about 43, 44. And then we jump up here to 20 centimeters of rain, and they found 60. And when there was approximately 23 centimeters of rain, they found approximately 61, 62 frogs. So what is the relationship between the amount of rainfall at the pond and the number of frogs in a pond? So in order to answer that question, we had to first look at the data. So here's the claim that I came up with. The relationship between the amount of rainfall at the pond and the number of frogs in the pond is that when there is more rainfall, there will be more frogs. Now, one of the common mistakes students will make is they'll really shorten it up and say, the more rain you have, the more frogs you have. Well, that claim is accurate, it's not complete. Did you completely answer the question? What is the relationship between the amount of rainfall at the pond and the number of frogs in the pond? If you simply said the more rain there is, the more frogs there is. Now imagine if you were reading your claim and they didn't know what sentence you were answering. For all, the person who is reading it might just assume that the question was, what happens when you have more rainfall? Oh, when you have more rainfall, you have more frogs. but by saying the relationship between the amount of rainfall at the pond and the number of frogs in a pond is that when there is more rainfall, there will be more frogs. So when we go back to the original question, it completely answers this. Now, where should your claim be in your CER? A lot of times your claims will be first in your CER, or not your CER, but in your scientific explanation. But it doesn't have to be. I've had some students put their claim at the very end. They've looked at all the evidence, they've stacked up the evidence, they've done their reasoning, and sometimes it's within their reasoning or sometimes at the very end. Therefore, the relationship between the amount of rainfall at the pond and the number of frogs in the pond is that when there is more rainfall, there will be more frogs. So, again, remember, claim is usually one sentence in length. Don't just answer it with a yes or no statement, and it must be accurate, specific, and completely answer the question. So make sure you look over the evidence, look over the scientific principles. Those will all help you develop a really good claim. So if you have any more questions about how to write a CER and how to work on the claim, make sure you ask me in class. Thanks.